Hey folks, Cale Kochenour here, back with another video to help you add a skill to your geospatial talent stack. This time we're sticking with open reproducible science, but this time workflow structure. How can I organize my code in a way that's rigorous and that will help set me up for success? Let's start again with the GitHub repository. This time the name is workflow structure. So the general premise of this repository is to get you thinking about rigorous workflow structure. So how can I organize my Python scripts, my Jupyter notebooks? And there's a couple competing philosophies. The first one here, so outlining, usually I have these 8 different steps or stages of the workflow that I incorporate into my scripts and notebooks. Some have all these steps in one. Some have this other structure down below where maybe you separate one step per script, where each step takes a certain input and then creates a new output for the next script to use. So within these two, I actually use I've used both of these structures. I use subsets of them depending on the different data, the input data, the output data. Maybe some organizational best practices or guidelines will influence us a little bit, and certainly personal preference. But these are the somewhat two competing philosophies that I've used and I do continue to use. So if I hop into, now we're in the 01 code scripts folder, this workflow template. The way I usually like to start off my scripts are to provide this kind of the script doc string where it's got information containing the purpose of the script, the functionality, any necessary input data, any output data that it creates, as well as maybe some user-defined variables that you need to set, not just for someone else if you're giving the script to them, but if you yourself come back to the script after a few weeks away, need to rerun it to maybe download some new data from an API, you know what folders to set, you know what parameters to set. I also like to include any other relevant ancillary information. Usually I like to add the folder structure. This is the same folder structure I mentioned in the project structure repository. And then finally, I like to add some author info, my own contact info, and then the license information for anyone who's interested. The next step, within this structure, I've got these 8 different workflow steps with template sections here. I like to organize it just with these comments as a way to kind of visually break it up so you know what section you're working in. And then finally, this script completion section. This is just an unambiguous end of the script to notify me or notify someone else when the script has ended. And the main point here, one of the main points is it's not necessary to have all these exact same names, have the definitions match up of what the stages mean, but just to start thinking about how do I organize my code in a way that is rigorous and useful to both me and someone else who I give the code to. So let me hop back to the main repository here. I'm going to open up Binder because I'm going to show the Jupyter Notebook version of this. As I open up Binder, it looks like it's spinning again. This could take a few seconds to load, so I will drop here and come back on the other side. Looks like that didn't take too long this time again. So if I open up the code scripts folder, open up this workflow template notebook, what you'll see here is the exact same sections that I mentioned before. I like to structure my notebooks or either have all of these or a subset of them depending on which steps I'm using and which data. The one big difference here, if I do a restart and run all, one thing you'll see here is this third cell here. I always like to back the working directory up one folder to the root directory of the repository. In this case, it's home Jovian, which is the default root for any notebook working in Binder. But now you can set relative paths, so you can add code, the code scripts folder. You can add a path to the raw data, to the process data, to your graphics and outputs, and as well to your papers and writings, and/or any other folders you add into your project structure. But that's the one kind of main difference here between the Python scripts. Usually with the Python scripts, I run them from the root directory, so I don't have to change the root directory at all, or don't have to change the working directory at all. But I always like to bump up one within these notebooks. So I close down that, leave page. Within Binder, I'm going to open up a terminal because I do have a couple scripts, a couple automation tools to run here. So if I open up terminal, I will go back to the make file. This time we've got 4 different routines. One actually to create the Conda environment to save you some time typing in the Conda environment. One to run the template script, which doesn't have any functionality other than producing the output. I've got this scripts routine. I've got this scripts routine that creates 5 new Python scripts as a way to introduce a new structure, and then this clean routine to get rid of some of those Python scripts to clean up. So if I do this first one, make environment, this is going to save me some time to having to type in all the commands to make the environment. This will take a few seconds to load, potentially up to a minute or a few minutes, so I'll stop here and see you on the other side. And we're back, and so looks like we have the Conda environment now. It's available. I'll clear it out. One thing to note, it's not completely necessary to create and activate the Conda environment for this because we're only using the OS package in Python, which comes with the base environment. But I do want to reinforce, same with the automation commands, I do want to reinforce the concept and implementation of the Conda environments as well as the automation. So to activate the environment, you type in conda activate and then the name of the environment. In this case, our environment's name is Reproducible Science. Once again, in the top left in parentheses, you can see which environment is currently active. So if I do a make run, this will run the template command or template script. Again, it's just a script filled with the different organized sections. You have the output message here, unambiguously showing the script is done. The next one I have here is make scripts. This is going to create those 5 Python scripts I mentioned. If I hop back to the O1 code scripts folder, you can now see these 5 Python scripts. And these are, certainly you can add scripts based on whatever workflow scripts work for your project or your personal preference. And then the final make, if I do a make clean, that will remove the specific 5 scripts I created here. So if I hop back to the main GitHub to wrap up here, coming back to this structure, so I've got a Python script and a Jupyter notebook with this main structure. And the general idea again is don't worry necessarily about what the names of the workflow stages are or how I name them, how I define them, because certainly there's maybe some crossover between definitions, personal preference will influence here. But the main idea to take away from it is to think about kind of pseudo-coding the structure. What's my input data look like? What's the output data look like? What kind of steps or structures do I need to get the input data to the output data as a way of pseudo-coding to create a structure for your project? And a lot of it will be, maybe, and a lot of mine are too, subsets of these different steps here, so you're not going to use all steps in all projects, but again, getting you to think about the rigorous structure and how to organize it is the more important takeaway than the actual names and how I name it. Thanks for watching. As always, I am Cale Kochenour. The description of this video has a link to the GitHub repository hosting all of this code that I demoed, as well as a Medium article that goes into a little bit more detail about the workflow stages and some of the ways I define them. Thanks again, and I'll see you in the next video.